Hello everyone. Today I'm gonna talk about debuggers. Today we're gonna talk about the GNU debugger. In short, we call it as a GDB. We'll talk about general strategy that you can use with for the debugging with GDB. It helps you to execute the program and to the point of the interest and by using the breakpoints and stepping to do that. And we will tell you how you can examine the values of the variable at the point. And we will go through the debugging example code, which implement the insertion sort. And we will talk about how you can use GDB to debug bugs in this insert sort program. Before we start, we want to talk about the typical steps for debugging with GDB. Before you start to run the GDB, you first need to compile your code especially. In most of cases, we need to build it with the -G option. We add a -G option, then it will add extra information to executable file that GDB uses. Additionally, what we can do is that we can add -O0 option. What this option does is that it will disable the compiler optimization. By doing so, it allows us to access more variables that could be optimized with the more optimized option. So you can compile your code -G, and additionally, you can add a -O0 option. And by doing so, you can add the debugging symbols to your program. After that, you need to run the GDB in a different terminal. To run the GDB, you can type GDB and the file name that you want to debug. You can also run GDB inside the Emacs or Vim or VS Code. And you can set the breakpoint if you want. To set the breakpoint, we can use a command called the break. Then if you set the breakpoint, then the program would stop at that breakpoint when it's executed. To add a breakpoint to the main, you can put the break main. If you want to put the breakpoint to the function named process data, you can set the break process data. Then your GDB will stop your program execution if it reaches to the first executable line of that function, main or the process data. Then what we need to do is that we want to run the program. To run the program, you can type a command called run, and then GDB will run the program, and it will stop at the breakpoint that we set. In here, if we set the breakpoint to the main and the process data, main is the first function that would be executed, so your program will stop your program at main. Then after that, if you want to continue the execution, you can type a command called continue. Then GDB will stop at the next breakpoint. In here, it would be the process data. Then you can step through the program as desired. There is a command called step. If you put it repeatedly, then GDB will execute the next line repeatedly. Note that there are two ways that you can execute a next line. There are functions named step. If you use the step, then it will steps into the function. So for example, there is a function call. If you type the step, then it will break inside of that function. If you put the next, then it will steps over the execution. In other words, it will execute the next line without stepping into the function. So these two functions are used to execute a single line, but they have these kinds of difference. So step will steps into the function, next will steps over the function. To examine variables, you can use a command called print. So you can put the print, and then you can put the the name of the variable that you want to examine. For example, if you want to print out the I value, then you can do the print I. If you want to know the print J, J's value, you can do the print J. If you want to know the temp value, you can do the print temp. Then GDB will print out the value of each variable. And when you do the debugging, you want to know where you are. In other words, you want to examine the function call stack. For that, there is a command called where. If you put that, then GDB will print out the function call stack. This is very useful for finding the problem when your program crashes in a very large program. And when you want to exit the GDB, you can type the quit. So how we can run a program with the command line argument? There are several programs that try to get the command line argument. For that, you need to type a run, and you can put the argument that you want. For example, if you want to run the program with two arguments, arg1 and arg2, you can put run arg1 and arg2, then your program will run with those command line arguments. You can also use the redirection when you run the program. So if you want to redirect in the standard input and you want to redirect out your standard out, then you can do the standard redirection similar to what you have done in your shell. And you can also print the values of the expressions. And also you can do the break conditionally. We will see how you can do that, those kinds of things. These are the materials so far are enough for basic uses of the GDB. But GDB has a lot of more functions for help you your debugging. So if you want, you can search the internet. There are a lot of good GDB resources would be there. Today, I'm gonna debug this program called insert_sort.c. So before I explain the code, let me tell you what this program is actually wants to do. So what this program is supposed to do is the following. The first one is that it tries to get the integer input from the command line, and it wants to sort them by an algorithm called insertion sort, and it wants to print out the result to std out. That's the intention. That's what it's supposed to do. For example, if we run the program with the argument 10, 15, 7, 51, then we expect that this program will output 1, 7, 10, 15, 50. So those numbers should be sorted and printed it out. I want to tell you what the insertion sort algorithm does is that it is iterative algorithm. Let's assume you have a already sorted algorithm, a sorted array. Initially, if an array is empty, it is already sorted. Then for each new input, what we try to do is that we find the right position that this number should be located in that sorted array, and we add that number there. And we repeat this again and again. And then until we process all input values, then we will get the sorted number. So let me give you the example. So say we have input 412, and initially the sorted array is empty. Then we want to add a 4, and we want to add it to the right position in this sorted array. In the empty array, the right position should be the first location, because we are empty, so we should put it at the first position of our sorted array. So the result array would be just 4. And we want to add 1. And we want to add it to the right position in the sorted array. To make our array keep sorted, we should put 1 at the start of our array. So we want to move our number 4 to the right side and we want to put the 1 to the first position of our array. So 4 is pushed down, and the 1 will be added at the position at the first position of the sorted array. And we want to add a 2, then we want to add it to the right position in the sorted array. The right position should be the second position in the sorted array. So we will move the 4 we will push down 4, and we will put 2 to the second position of our array. So we repeat it, then we will get the sorted array. Okay, so this is what this program does. Let me see how we implement it initially. We want to see our initial implementation for this insertion sort. So here is the function. So we include the headers, and we have 4 global variables: x, y, num inputs, and num y. So we have these 4 inputs. X is an array for storing our input. Y is the array that we will use for our sorting workspace array. Then at the end, this Y will contain our sorted numbers. And the num input represent the length of the input array. How many array exist in our how many inputs are given to this program. It represents that number. And the num_y is the current number of the elements in y. So we repeat it until num_y becomes a num input. And this is a function getArgs. What it does is that it tries to get the argument from our standard, from our command line, and we want to convert it into that number to the numbers, and we want to add it into our input array. So for that, it gets 2 arguments. AC stands for the number of the argument, command line argument, and this is the array that stores the command line argument. And here we first we initialize num inputs with the AC -1. The reason why we subtract 1 is that the command line arguments already contains the default argument, which is the program name, at the first element of the argument vector, argument array. So because of that, we need to subtract 1. And our real argument starts from the AV1. So this is why we need to add 1. It should be I plus 1 instead of I. So it should be I plus 1. So this is the reason why we need to have this I plus 1. So we repeat it until the num inputs, and we store our number. We store our arguments as a number to this x. So what this program does, in short, it gets the command line argument and convert them into the number and store it to the x. And we initialize x and the num inputs. That's what this function does. And this function, what this function does is scoot over. You can think of this function as a push down. So if we give the JJ, it tries to move all the elements from JJ. We want to shift by 1 all inputs from the JJ. So the purpose of this function is we want to make a whole. So after we find a right position, we want to move our numbers shift by 1, and we want to put that number at that position. So we want to make a whole. So this is what this function does, scoot over. And this is a function named insert new. What this insert new does is that if we have an input new y, then we want to put this new y at the right position. That's what this function tries to do. So if num_y equal to 0, which means that if y is empty, then we want to put this number to the first position of the array because that is the empty array. So we get the number, then we should put it to the first position. So this is handling the base case of the insertion sort. If it is not the case, we already have some numbers. Then we have a for loop, and we try to find the right position. If when uy is less than the yj, means that this is the right position that we need to push. Then we shift this starting from the j, we need to shift all the numbers by 1, and that's what scoot_over does. And we want to put that number, num_y, to the yj, and we return. So this is what this function does. If we get a new number, we'll want to add it to the right position. And this is the function that tries to sort that number. What this function does is that it repeats this insert new process until we process all the numbers. Okay, so we repeat it from x num_y equal to 0 to the num inputs. So we repeat this insert new and again and again. And this is the function that tries to print result. So our program, our program does is that it tries to get the input and it tries to sort all the numbers and it wants to print the results. Okay. Okay, so let me show you. Okay, let me start with the let me start it with the example. So before that, I want to copy my code. Sorry, it is not insert code, but insert sort. Let's see. Okay, so I copy all the code and check. I want to compile this code. And I want to run this program. So what I expect is that if I run this program with 15 and 10, it should give me the 10 and 15. But if I run this program, it will stop there. It will fall into the infinite loop. So this is not something what I want. So let me try to debug it. So before I debug it, I want to compile my code. So sort C minus G minus O equals 0 minus O insert sort. Okay, so I want to compile it with minus G and the minus O option. And let me run the GDB and run it with 15 and 10. And then let me press the Control C. So it is stopped at the insert new. And I want to print out what is num_y value. Num_y value is 0. Okay, that's strange. So if I stop it, then I can stop it here. And if I check what is num_y value is 1. So I believe there is something bad happen. So let me break this insert new if my num_y is 1. So for conditional break, what you can do is to put break and the function name and the put if, and you can put your the condition that you want to break. So let me break if my num_y is 1. So let me run this program. And I hit here. And if I type next, and if I type the next, then something bad happens. What it means is that my num_y was 1 here. My num_y is 1, then it should fall into the for loop. my loop is just stopped, just finished. It skips this loop. Why it happens? So let me check. If I type the next, then when I run this for loop, if I print a num-y value, it becomes the 0. That's strange. In this insert new, it was 1, but after I type this next, it becomes 0. What's wrong here? Yeah, you can easily catch that. If you check this line should be the equal check, but this is assignment, right? So because of this assignment, num-y always becomes 0 after we execute this line. So this is the bug that we need to fix. So where is that line? So let me fix it. Yeah, it should be equal. And I compile it again, and let me put the 15 and 10. Okay, now it seems better because it is not going into the infinite loop. But the problem is that it is not the input that we expected. What happened to the 10? Because if we give the 15 and 10, so if we give a 15, then it works well. But if we start to give a 2 input, something bad happened. So let me try to debug this program. So I want to set the breakpoint to the insert new if my new y equals to 10. So let me run it. Okay, so I'm here. Next. If I put the next, if I put the next, then it does the scoot over. So let me check the y. Okay, y is this function. Y is this array 15 0 0 0 0 0. And what is my j? My j is 0. So what I expect is that if I do the scoot over 0, the resulted output should look like this. Okay, that's what I expect. So my array should be moved, and then it needs to print out this one. My array should be look like this, and then I will put 10 here. That's my intention. But if I type the next, so scoot over is finished. But if I type y, oh, this is still 15 0 0 0, not 0 15 0 0 0 0. So what's happening there? So what I can see is that there is something wrong with my scoot over, right? So let me check the source code of the scoot over. So there is a command in GDB called the list. Then I can check the code inside of the GDB. So let me check this code, scoot over. If my JJ is 0, in this case, J was an input and it was 0. And if my num1 is 1, okay, then what it does is that it tries to start from the 0 until the k is greater than the 0, right? So what it means is that this for loop will be never executed because 0 is not greater than the 0. So AJ is 0, num1 is 0, so num1 is 1, so num1 minus 1 would be 0. So this is k equal to 0 until k is greater than the 0. So this is something that this for loop will be never executed. But this is not something that we want. In that case, what we want is that we want to move a value at the 0 to the right position, right? What's wrong with this code? Actually, we need to start our for loop from the num_y instead of num_y minus 1. because the num_y is the last element that we want to. So num_y would be the new last of the increased array. So what we want is that we want to have the y1 equal to y0, right? We want to move our element at the 0 to the shift right. So that's what we want. But if k is a num_y minus 1, then that would not happen. So k should be the num_y. Okay. So let me fix that. It's good. Over. It should start with the num_y. Okay, good. Okay, let me run it. Oops. I think something looks more bad thing happened. So if I run this program, it does not work, but it gives me a segmentation fault, which means my program is crashed. But let's see what happens here. So if I put the run 15 and 10, oops, it crashes at the scoot over. So if I type the k, it is 9786. And if I type a num_y is 1. So what's wrong with that? If I check the scoot over, okay, this function. So what my intention is that from the last element, I want to move all the element in the left side, and I want to shift it by 1. That's what I wanted to do. For that, my k should be decreased, not increased. But now it is increased, so it will be increased again and again. So because of that, it will not have any limit. So k becomes a very large input, and it will trigger the stack overflow, and it crashes the program. So my k should be decreased, not increased. So I need to change k++ to the k-. Okay. After that, if I run it, now looks good. So okay, so my program works. I'm done. Unfortunately, it is not the case. If I give another input, that's the reason why we need rigorous testing. So if I give some other input, 15, 10, 16, 8, it gives me a wrong result again. If it is if I give this input, what I expect is 8, 10, 15, and 16, but my 16 is gone. Okay, so I want to debug this. So for that, I want to break insert new if my new y is 16 and to run this program with this input. Then I'm here. I type next. Oh, you can type n instead of next. So let me type n and n and again and again. So if I print y, what I expect is that, so my input was 15, 10, 16, right? So what I expect is the 10 and 15, and I should put my 16 here, right? But unfortunately, if in this function, in insert new, my insert new is finished without adding 16. So this is the this is the y after my insert new is finished. But in this case, what I expect is that my output should be 10, 15, and 16. But this is just the 10 and 15. So my insert new is finished when my input is 16. Why it happens? So let me take a look at the code. So in this insert new, so we try to check where the right position if y is non-empty. But if we cannot find any good position in this for loop, if we could not take this branch, then if all elements are less than my ui, in other words, ui is greater than equal to the all elements, then it just reached to the outside of this for loop, but it never adds our input, our new I to the array. This is not something that we want. We should put this new y at the last of our y. So we should put the y, num y, equal to the new y. Okay. That's what we need to put. Sorry. It should be y num y equal to the new y. So we should put here. Okay. After did that, okay, we fix all the bugs. So if we run it, yes, it will give us a right result. There are many other things that you can do with the GDB. So there are a lot of types of the breakpoint. You can break to the line. If you give number, then it will put the stop at the line number. And if you have multiple files, you can specify that file with the file name.c colon, and if you put the line number, then it will stop there. And you can also add a conditional breakpoint. And info breakpoint will show you all the breakpoint that you set, and you can delete those one by putting this number from the info. And you can also, there is another special type of breakpoint. If you put the watch, then it stops if that value of the expression changes. So for example, if you have a watch I, then it will stop when the value of I changes. Okay. And you can put some more complicated expression. So expression is quite flexible. And I showed this command. If you put the list, then it will show you the source code. So if you put the list, then it will show the source code of the current context. And if you put the list func, then it will show you the source code of the function. And where we already talked about this. And if you have the call stack, you can go up and you can go down in this call stack. So if you type up, you will go up to the caller function. And if you go down, it will go down to the callee function. And we talk about continue. And another one is that you can, there is a command called until. So if you put until, then it will execute the program until the current loop ends. So if you are inside the loop, that it will do it until your loop ends. And there is another way you can you can continue the program called the finish. If you put the finish, then it will execute the code until the current function return. So there is a way that you can do using there is another technique called the core dump in when you try to debug your program. If you are interested, you may find it, but I believe using GDB is enough in most of cases, so I do not want to tell about this. Okay, so let me talk about the assignment. The assignment for lecture 5 is just to follow the instruction that I did before with this insert sort.c. So just follow my instruction, and you need to just replay what I did and fix all bugs in the insert sort.c and just submit that file, the file that I just created. Give that file to KLMS. One thing I want to mention is that you should not put the screenshot or the JPG, but you need to give us just a source file. For this assignment, you need to use GCC instead of GCC 209. The reason is that GCC 209 is much safer. So because of that, you even cannot compile the code with the GCC 209 due to a compilation error. So for this tutorial, for this debugging example, you cannot do it with the GCC 209. And please name the file with your student ID, insert.c, and please upload it to the KLMS. That's the thing that you need to do. Okay, good. Then I think this is the end of today's lecture. I hope you have a great weekend. Okay, bye-bye.